Most people think the hottest planet in the solar system should be Mercury, because Mercury is the closest planet to the Sun, sitting only about 58 million kilometers away from it. But that's not actually true. The hottest planet is Venus, even though Venus is almost twice as far from the Sun as Mercury. And that immediately tells scientists something important. The temperature of a planet is not controlled only by distance from the Sun. Atmospheres matter more than most people realize. Because while Mercury has almost no atmosphere at all, Venus has one so thick and extreme that it completely traps heat across the entire planet, turning Venus into what is essentially a planetary-scale pressure cooker. And the numbers are difficult to even imagine. The average surface temperature on Venus is around 465 degrees Celsius. That is hot enough to melt lead. Not in certain regions, everywhere. Daytime and nighttime temperatures on Venus barely change because the atmosphere distributes heat so efficiently around the planet. On Earth, deserts cool significantly at night because heat escapes into space. But on Venus, the atmosphere is so dense that thermal energy becomes trapped almost permanently through an extreme version of the greenhouse effect. Sunlight enters through the clouds, heats the surface, and then infrared radiation trying to escape gets absorbed and re-emitted repeatedly by thick carbon dioxide layers, trapping enormous amounts of heat near the planet. Scientists call this a runaway greenhouse effect, where warming triggers more warming in a self-reinforcing cycle. And that atmosphere is not just hot, it's crushing. Venus has a surface pressure around 92 times greater than Earth's atmospheric pressure at sea level. To understand how extreme that is, it's roughly equivalent to standing nearly 1 kilometer underwater in Earth's oceans. If a human somehow appeared on Venus without protection, the heat alone would kill them almost instantly. But even if the temperature didn't exist, the pressure would still be catastrophic. The atmosphere is so dense that near the surface, air behaves almost more like a fluid than a gas. Moving through it would feel thick and heavy. And the clouds themselves are toxic. Venus is covered by permanent clouds made primarily from sulfuric acid droplets. These clouds stretch across the entire planet, reflecting so much sunlight that Venus becomes one of the brightest objects visible from Earth's night sky. Ironically, Venus looks beautiful from far away because of how reflective those clouds are. But underneath them is one of the harshest environments in the solar system. And the deeper scientists studied Venus, the stranger it became. Because Venus rotates in the opposite direction of most planets. This is called retrograde rotation. On Venus, the Sun would appear to rise in the west and set in the east. Even stranger, Venus rotates incredibly slowly. One full rotation takes about 243 Earth days. That means a single day on Venus is actually longer than an entire Venusian year, because Venus orbits the Sun faster than it spins on its axis. Scientists still debate why this happened. One major theory suggests Venus may have experienced enormous collisions during the early formation of the solar system, altering its rotation dramatically. But despite rotating slowly, the atmosphere moves incredibly fast. This is one of the weirdest things about Venus. The upper atmosphere circles the planet in just a few Earth days through a process called atmospheric superrotation. Winds in the upper cloud layers can exceed 300 kilometers per hour, moving far faster than the surface itself rotates. Scientists still don't fully understand why Venus's atmosphere behaves this way, making it one of the great unsolved problems in planetary science. And then there's the surface. Radar mapping from spacecraft revealed a landscape filled with massive volcanic plains, giant shield volcanoes, collapsed lava channels, and deformed terrain unlike anything on Earth. Some volcanoes on Venus may still be active today. Recent observations from missions like NASA's Magellan spacecraft data suggest certain volcanic vents may have changed shape over time, hinting at ongoing geological activity. That matters because volcanism releases gases into the atmosphere, including carbon dioxide and sulfur compounds, which could continue feeding Venus's greenhouse conditions. And unlike Earth, Venus does not appear to have active plate tectonics. On Earth, tectonic plates constantly move, recycling carbon and helping regulate long-term climate stability through volcanic and geological cycles. Scientists think Venus may lack this type of planetary recycling system. Without efficient cooling and carbon regulation, greenhouse gases accumulated in the atmosphere over immense periods of time, helping push the planet further into extreme warming. Early Venus could have had liquid water oceans billions of years ago. Temperatures may once have been stable enough for long-term surface water to exist. And if liquid water existed for extended periods, then Venus may once have had conditions potentially suitable for life, at least microbial life. As the young sun gradually became brighter, Venus received increasing amounts of solar energy. More heat caused more water evaporation, but water vapor is itself a greenhouse gas, meaning the atmosphere trapped even more heat, causing even more evaporation. Eventually, the oceans may have completely evaporated into the atmosphere. And then, ultraviolet radiation from the sun began breaking apart water molecules in the upper atmosphere through a process called photodissociation. Hydrogen escaped into space because it is so light, while oxygen reacted with surface materials and atmospheric chemicals. Over time, Venus permanently lost most of its water. And once the water disappeared, one of the planet's most important climate regulation systems disappeared with it. Because on Earth, water plays a massive role in controlling temperature, weather, erosion, and carbon cycling. Remove water, and planetary climate stability becomes much harder to maintain. And this is why scientists are obsessed with Venus. Because Venus may represent what happens when an Earth-like planet crosses a critical climate threshold. It may be a warning about how planetary systems evolve when feedback loops spiral beyond stability. Venus is only slightly smaller than Earth,